All right, here we go. Unit 1, Lesson 5. We're going to break this one into two parts as well. This kind of section is arithmetic combinations of functions. So what that means is that not only can we take f of x or take g of x, but we can combine functions together. We can add them together. We can subtract them. Looks like it's going to stay yellow. We can multiply them, or we can divide them. So again, when we look at things like the domain, again, if the domain has to work for both f of x and g of x. Otherwise, it won't produce a real solution. So again, you have to use numbers that work for f of x and g of x. But let's do an example. So we can kind of just look at it, kind of a real simple example. Let's look at f of x plus g of x. And so for all of these, we're going to use the same we're going to use the same functions for f of x and g of x. So f of x is 2x minus 3. G of x is x squared minus 1. So if I'm solving this first one, I'm going to go ahead and I'm going to say, well, f of x is 2x minus 3. G of x is x squared minus 1. So I'm going to go ahead and combine like terms. I see I've got a like term here and a like term here. I really don't have that many like terms. I put the highest exponent first, x squared plus 2x, negative 3 minus 1 is negative 4. So again, we're just going to run through these real quick. We're going to subtract them, see what we get. Going to start with the exact same problem, but I'm going to subtract it this time. Don't forget, this negative gets distributed to each term. So I get 2x subtract 3 minus x squared. Subtracting a negative is adding 1. I still only have one like term. So again, negative x squared plus 2x subtract 2 this time. Let's go ahead and multiply them. F of x times g of x. Two x subtract 3 multiplied by x squared subtract 1. Using the distributive property, again, into both terms. Let's see what happens. 2x times x squared, 2x to the third, 2x times negative 1. To negative 3 times x squared, and negative 3 times negative 1 is positive 3. So again, actually don't have a single like term here. 2x to the third, I always have to put the highest exponents first. So I'm just rewriting it in standard form. And that's my answer. And last but definitely not least, we can take f of x and divide it by g of x. So when I do that, I say, 2x subtract 3 all over x squared minus 1. I really can't do much with that because I can't really cancel out anything. But notice again, my domain, I can't ever have a 0 in my denominator. So x cannot equal 1 or negative 1, because if it did, 1 squared minus 1 equals 0. Negative 1 squared minus 1 equals 0. So those are the numbers that I cannot have my answer equal. So we can kind of take it like that. There are other ways to do it as well, like different examples. Like say we want to actually evaluate it. So let's jump to, we'll do, again, if you look at kind of how we can write these, f plus g of x. That really means f of x plus g of x. Mathematicians are notorious for wanting to shorten things up. So if there's a shorter way to write it, we're going to write it. So find f plus g of x, and then evaluate when x equals 2. And so my functions, again, this is given to you. F of x equals 2x plus 1. G of x equals x squared plus 2x minus 1. So again, I'm going to copy this right here, and I'm going to say copy, paste, perfect, equals f of x, 2x plus 1, plus g of x, x squared plus 2x minus 1. I see I've got like terms here and here. So equals x squared, 2x plus 2x is 4x, and 1 minus 1 cancels out. So that's what I get, x squared plus 4x. And then because the question asked me to solve when x equals 2, I'm going to say, well, f of 2. So again, if I'm keeping my same form, I don't want to jump around. It'd be f plus g of 2 equals, every time I see an x, I'm going to write a 2. 2 squared is 4 plus 8. So f plus g and evaluated at 2 equals 12. So we're going to take these exact same functions and we're going to do another example. Copy that. We're going to find the difference quotient. So very similar. Paste. Kind of didn't put it in a, let's go back a step there. Put it more in the middle. Okay, so again, same problem, haven't changed it, but I'm going to do f minus g and then evaluate it when x equals 2. So again, I'm going to say, let's go ahead and plug it in and just say 2x plus 1. I'm going to use parentheses because I know that when I have subtraction, I have to distribute that negative. So I'm going to just remind myself here, here, and here. So I'm going to rewrite 2x plus 1 minus x squared minus 2x plus 1. I've got like terms here, and I've got like terms here. So when I rewrite it, f minus g of 2, I get negative x squared. These cancel out, plus 2. And then all I have to do is every time I see an x, I'm going to plug in that number 2 and get negative 4 plus 2, which equals negative 2. All right, let's keep going. Let's do a product example. Nope. Paste. Okay, here's my functions again. And this time it is a product. So again, it's going to be fg of x. And again, actually, we are going to use different functions. I apologize. This one, we're going to use different functions. So our functions are f of x equals x squared, g of x equals x minus 3. And then I want to evaluate when x equals 4. So I'm going to write it as fg of x. I'm not going to put x because I know I'm looking for it when it's 4. So again, x squared multiplied by x minus 3. Got to distribute. So this is going to equal x squared times x is x to the third. X squared times negative 3 is negative 3x. And every time I see an x, I don't want that. Every time I see an x, I'm going to plug in a 4. 4 to the third minus 3 times 4 squared. 4 times 4 times 4 is 64. 4 squared is 16. And 16 times 3 is 48. 64 minus 48 gives me 16. So f of g of 4 equals 16. And our last example for today, we are going to use a few different functions. So in this one, we are going to use f of x equals the square root of x, and g of x equals square root 4 subtract x squared. And then again, because of that division, I am going to want to double check that I have proper domains. So I'm going to say the square root of x on top divided by the square root of 4 minus x squared on the bottom. And I can't really do really much else of this one because I wasn't given what x was. So this is all I can do. Again, let's maybe say, hey, what if they asked you to write g divided by f of x? Okay, that would flip-flop it, but I bet you my domains may change. So let's go back and think about that. So the domain of the first function, right here, my domain is any number that is 0 all the way to infinity, because I can't take the square root of a negative number. So again, anything that is bigger than 0 is going to get me my answer. This one's a little trickier because again, I've got 4 subtract x squared. So if I think about that, if x squared is larger than 4, I'm gonna get a negative number, and I can't have a negative number. So what I need to do is I need to say, 2 squared is 4. Negative 2 squared is 4. So any number that's between negative 2 or positive 2 will work. If I plugged in a 3, let's hypothetically say I wanted to plug in a 3, 4 minus 3 squared, 4 minus 9. Uh-oh, I'm starting to get that negative number again. So that's why any number that is in between negative 2 or 2, and it can equal 2, that's totally okay, is going to work. All right, so we got to put it all together. So now if I look at f of g, again, I'm looking at this bottom part, okay? So I see that, hey, I know that my denominator cannot equal something that is negative. So my domain for this function is going to be, it could be 0. It could be 0. It can't be 2, okay? It's got to be somewhere in between 0 and 2. And very similar, again, why can't it be 2? Because I can't have a denominator of 0. And then for g divided by f of x, I could say, all right, my domain, again, using these domains that I kind of calculated, again, my answer cannot be 0 in the denominator. So it could be 0, but because of this one right here, I can only go high enough for 2. So my domain is for these functions is only